Hello, welcome everyone to this presentation on a way forward to harmonize emission factors of biofuels. I'm Khandelwal, Technical Manager at Smart Freight Center, and together with my colleague Tharsis Teo, we would like to present the Smart Freight Center views on the project that we did on comparing the emission factors of biofuels from various LCA databases based on US and Europe. So moving on, I will first like to introduce the Global Logistics Emission Council framework and the Low Emission Fuels and Vehicle Program, which is part of the Global Logistics Emission Council. Then further on, I will provide the background information on the project that we did under this program. Uh, Moving on towards the comparison of the LCA databases that we used within this project. Then further on, we will discuss the results and then we'll see what discussion came out of it and what the Smart Trade Center recommends out of this project. This slide needs no introduction. Based on the International Transport Forum outlook, the transport sector as a whole is responsible for almost 25 to 30% of energy-related greenhouse gas emissions. Within that, the freight sector is responsible for one-third of those emissions. If this business as usual case continues, we are looking at the increase of 42% of logistics emissions by 2050. We at Smart Freight Centers are trying to reduce these freight emissions by zero by 2050. What is Smart Freight Center is doing in this urgency? Smart Freight Center is guiding the logistic industry to zero emissions by 2050. We do this in several ways, and one way is standardizing the calculation of emission factors. When you talk about standardizing, this falls under the Global Logistic Emission Council framework, which is one of the initiatives where member organizations are jointly educated about emission calculations and reporting activities. Within that comes Low Emission Fuels and Vehicles Program. The main objectives of low emission fuels and vehicle programs are to look at the emission reduction solutions, provide guidelines on how to decide between the fuel or powertrain options, and support the emission calculations reporting in line with the GLEC framework as well as the upcoming ISO 14083. While looking at the scope of the low emission fuels and vehicles programs, this year we worked on the biofuels, looking at its sustainability and its production processes. We think at Smart Freight Centers that the biofuels can play a short-term role in decarbonization. It can act as in drop-in fuel until the electric vehicles and fuel cell vehicle matures. For the next year, our focus would be on road freight electrification. Now we are going to look at what are the four steps towards calculating our emission based on the GLEC framework. Step one is collecting the data. Step two, making the calculations. Step three, verifying and validating the calculation in line with the GLEC framework. And step four is reporting our emissions. Within the step one, collecting the data, you calculate the fuel emission factors. Now, the fuel emission factors can be from the various databases such as the GREET, JEC, or RED2. But here for the simplicity, we are getting the data from the GLEC. This value can be in various different units. It can be CO2 equivalent per liter, it can be CO2 equivalent per megajoule, or it can be CO2 equivalent per kilogram. What are the various challenges while calculating these fuel emission factors? First of all, while someone is looking at the fuel emission factor, the major challenges is like identifying which fuel emission factor would be relevant for the fuel usage. Because of various locations and geographies that fuel emission factor comes from, there are major differences in the values. This makes it more complicated in the current situations for someone who has different operation in different regions. Due to presence of the multiple databases, a user is confused which fuel emission factor he has to use while reporting his emissions. This collect data can always be replaced by different LCA database such as GREED, RED2, UKBIES. Looking at the highlights of the project that we did at the SFC, we found out various challenges while comparing various LCA databases. There was a challenge regarding the potential of biofuels to reduce greenhouse gas on a life cycle basis due to wide variety of feedstock supply chains and use cases available, which were based on different methodologies for emission accounting. The transport operators were lacking to find the comparable sets of emission factors at a global level due to inconsistencies in greenhouse gas accounting rules among emission factor developer, regulators, and the standard developers. The inconsistency between emission factor developers and standard developers were causing confusion among the end users in terms of accounting for the reporting structure. There was a distrust in market for the low emission fuels such as biofuels. Scope of this project consists of comparing the GREED, which is a US-based model, LCA model, with European LCA databases such as JEC version 5 and RED2 to provide transparency into different emission accounting principles, and how we need a consistent approach across different emission databases and geographic regions for necessary harmonization of emission factors. Now, moving on to the analysis, we compared the scope and methodological approach of these different LCA databases along with the qualitative analysis of emission categories. Then we did the quantitative analysis of emission numbers from these databases, which are represented in the result sections in the upcoming slides. First, we will talk about the overview of scope and methodological approach and how comparing these three different databases lead to different results. When looking at the GREET model, the tailpipe emissions are separately mentioned and categorized as compared to the JEC or RED2 typical values in Europe. The GREET values are regularly updated every year, while the JEC version 5 was launched back in 2020 and the RED 2 was launched way back in 2018. When looking at the allocation approach, the GREET model uses an hybrid approach, which is a mix of attributional as well as consequential approach, while the JEC uses consequential approach and the RED 2 uses the attributional approach. The ILUC values are more consistent and robust in the GREET because they are based on the C-CLUB and GTAB biomodel, while the JEC and the RED2 consist of the ILUC values which are based on the RED2 values only. Over to the quantitative analysis, we can see from this graph that we compared various biodiesel emission factors from the US with the EU databases. What we have seen from these graphs in comparing the crop-based fuels, there is a slight of difference between the values because in the US most of the feedstocks are grown locally, while in the Europe most of the feedstock that are used in the production of these biofuels are imported from various regions. If you look at the ILUC values as it can be seen in biodiesel soybean, the GREET value is 9 gram per megajoule as compared to the 55 gram in the RED2 typical values, which is also included in the JEC version 5. While also when we look at the time to wheel values, which are the operational values, the European databases consider those values as zero because whenever they are used in a vehicle, the biofuels values are all are zero. While in considering the GREET model, they do not consider these values zero because they believe there is certain non-pollutant or pollutant emissions coming out of the tailpipe whenever we are using the biofuels. Now, continuing with the quantitative analysis, when we look at the comparison of bio-LNG emission factors in within the US and the EU, we can see there is a lot of difference within the GREET and the European LCA databases. The differences in these fuels are due to avoided emission credits. There's a challenge that is ongoing between the LCFS and the Greenhouse Gas Protocol on how to harmonize these avoided emission credits as the avoided emissions are included to the carbon intensity for biofuels in the case of low carbon fuel standard, while the Greenhouse Gas Protocol does not include the avoided emissions into the scope 3 to get the final well to tank values. Now, moving on to the discussion part, what we learned from this paper, that what are the consequences of these inconsistency across sources, and what would be the impact on the transport operator or the end user who are using these emission factor databases. What we have found that this can eventually lead to an inaccuracy in accounting and reporting for multimodal operators which are operating globally. This can also create an uncertainty in the market for the on which emission factors to use, and thus impacting the market for users of low emission fuels such as biofuels. Looking back at the study and the project, we found out there has been so many distinctions between different LCA databases when it comes to emission factors. For smart grid centers, these are the following recommendations we think would be helpful to reduce those confusions among the emission factors. First, we need to address the inclusion of methane slip, avoided emissions, biogenic industrial removals in greenhouse gas accounting principles to make sure that there is no inefficiency in accounting and reporting of emissions, and it could help in fast-tracking the decarbonization efforts in the freight sector. Second, we need to come up with a reliable calculations for the ILUC emissions so that it can be included in the freight emissions reporting. Third, we need a program where the emission factors based on the credits can be incentivized so that it helps the fuel market producers of biofuels. Fourth, we recommend that we need to bring together a consortium of organizations for developing an internationally recognized sets of emission factors which are completely transparent and which can encourage the emissions reductions in the freight sectors. Thus, we can agree based on the study there are inconsistencies among various LCA database based on different geographies. From the fleet perspective, biofuel can act as a short-term decarbonization part, but for the future, the electrification of the fleets would be necessary if we are looking at a long-term decarbonization. Therefore, I thank you all for joining this presentations. If you have any questions, please feel free to reach out to me or Tharsis. I would be putting the publication in this chat. If you have questions now, I'm happy to answer them now. Thank you.